Dear students, in the previous class we have gone through this basic definitions of the various things like what is a database, what is data, mini world, database management system, then the database system. Now we will discuss regarding the simplified database system environment. Here we have everything that we have seen in the previous class. That is, we can see over here database system, DBMS software, then we have store database, everything over here. Now we will see in detail. At the top you can see there are users or the programmers. Programmers are the people who actually program the application and give it to the users. Then end users make use of these applications and they use it for storing some information, all these things, right? Whenever a user requests some information from a database which is already created and stored, now what happens is whenever a user requests something, there's a query is being created, then it is passed on to a DBMS software. DBMS software has two parts. One is software to process the queries or the program, and the second thing is software to access stored data. Whenever some queries have to be executed, what happens is the data that is already stored in the database has to be fetched. Now it makes use of software to access stored data part over there, and whatever the information is required, it fetches it, then it processes that data, then it gives information to the user. And whenever DBMS software it wants to access the data that is stored in the stored database, what happens is first you can see over there we have on the left hand side we have a stored database definition which we call it as a metadata. Whenever some information has to be accessed or we want to store some information, first the DBMS software will look at this metadata. If you want some information, then it will look at the metadata, then it will access the information that is stored in the stored database. This is how our database environment looks like. Now we will see what are the functionality, for what reason we are using this database management system software. The first use of this DBMS software is it is used for defining a particular database in terms of its data types, what kind of data type value have to be stored, what is the structure of the elements that are going to be stored, and what are the constraints under which a database has to operate. All these things are done by this DBMS software. After the database has been constructed, the next thing is constructing or loading the initial database contents on a secondary storage medium. That is, when we have created a database, apart from that, when we insert some information, when we store some information, that has to be stored somewhere permanently. So we'll be making use of this secondary storage medium. Then we have functionality like manipulating the database. The first one is regarding the retrieval. Here we are making use of the queries. Whenever we want something, whenever a user requests something, a query is being generated, then the queries are being processed and the answer or whatever the things is required by the user will be given to the user. Then we have generating the reports. DBMS has a facility to generate the reports and give it to the users. Then next one is a modification. Modification is nothing but if you are inserting something in a database, or if you are deleting something from a database, or if you are updating the content of a database, we call it as a modification process, which is again supported by the DBMS software. Then accessing the database through web applications. We can have our own web applications and we can request something and that data is given to the users. Apart from this, the main reason why we use a DBMS system is it helps us in processing and sharing by a set of concurrent users and application programs, yet keeping all data valid and consistent. That is, at the same time, many people can log in into the system and then they can view the information or they can update the things, and at the same time they can share the information. Everything is possible. Here it supports concurrent using of the database, so it has got its own applications. Apart from the basic functionalities, now we will see at typical DBMS functionalities, the other features of a DBMS. The first one is protection or security measures to prevent unauthorized access. What we can do by making use of this DBMS software is we can have a protection of our data, we can have a security of the data whatever we are going to store in a database. We can allow only a particular group of users to access the data. We can create the users and we can assign them, okay, these are the people who can modify the data, these are the people who can just look at the information, or these are the people who can modify the data, all these things. We can give the permissions, again, which is possible because of this DBMS software. Then we have active processing to take internal actions on data, whatever the data that is being stored, everything. We have a set of procedures through which the data is being stored and retrieved. Then presentation and visualization of data. We can have our own look and feel of the data. Then maintaining the database and associated programs over the lifetime of the database application. Apart from the general applications or the functionality provided by the DBMS, DBMS has its own responsibility for taking care of the information or the data that is stored in the database, because there are some database which are used for a much longer duration of time. So it has to look for all these things. Now let us consider an example of a university database. We are familiar with this university database. We know in a university, we will consider a mini world as a university over here. That is, we are going to restrict our database to a only one university over here. So that's a mini world for us. So it is having the entities like student entity, course, sections of the various courses. Then we have departments, academic departments, then instructors who belong to a particular department over there. So for us, everything is an entity, whether it's a student, course, section, department, instructor, everything is an entity for us. Now we will see over here. Here we are going to study something regarding the relationships. As I have already said in the previous slide, courses, they are of particular sections, right? See over here, sections are of specific courses. That is, each course has its own sections. So there is a relationship between sections and the courses. Then we have students take sections. That is, takes is a relationship between student entity and section. In the same way, courses have prerequisite courses. Consider an example. A course like if you now you are studying database management system. If you want to study data structure, you should know some basics of C programming. And if you want to study DBMS subject, then you have to know something regarding C programming. Apart from that, you need to know a data structure concept also. That is the thing. That is, if you want to undergo a particular training in a particular course, then you have to study a particular subjects. Then instructor teach sections. That is, teach is a relationship between an instructor and a sections. Like this, you have courses are offered by departments. Students major in departments. Everything here like take, prerequisite, teach, offered, major in. All these things are the relationship between the two entities. We can consider an example of a simple database. Here we have taken the entities like course, section, grade report, then prerequisite over here. You can see we have a table, a course table. A course table is nothing but a course is an entity over here, which is having the components like course name, course number, credit hours, department. Everything is a part of course table, right? In the same way, we have a section. It has section identifier, course number, semester, year, instructor. Everything is a part of this section. In the similar way, we have grade report. Then we have prerequisite. So this is a sample simple database over here. Now we will consider the main characteristics of the database approach. First one is self-describing nature of database system. What do you mean by self-describing? Self-describing is nothing but it explains itself, right? If I consider a database, each DBMS has its own catalog. What it does is it stores the information regarding the particular data that we have stored. A DBMS catalog stores the description of a particular database. Example, like what are the data structures involved and what are the data types and what are the constraints under which a particular information has to be uh, stored, everything. For all these things, we have a catalog. The description is called a metadata. You can see over here, this is an example of a simplified database catalog. We can see at the top we have a relations which tells us in this particular database what we have is the different relations uh, like student, course, section, grade report, prerequisite, everything, the name of the various tables over there. Apart from that, number of columns. If we consider a course table, in the course table we know that there are 4 columns. We can just see over here. The course table is having 4 columns, that is course name, course number, credit hours and department, right? In the same way, section has 5 columns, grade report has 3 columns, prerequisite has 2 columns, all these things. Then we will see in detail like what are the things that we have stored in a column. If we consider our first table, that is a student table, which has name, student name, class, major. So these are the 4 attributes of this student table. And apart from that, name is of data type character 30. We can store at most 30 characters in that. Then we have student number. Second one is a student number, wherein we can store at most 4 characters. Then class, integer. It is of type integer. We can have like numbers 1, 2, 3, 4 like this. Only numbers can be stored over there. Integer numbers can be stored. Then we have major, which is of type major type, which is a user defined data type over there. We will see regarding the data types in the upcoming classes and all. So this is, by looking at this, we can come to know how many tables are there in a database or how many relations are there in the database. Then apart from that, what are the contents, like what are the columns and what are the data types of that and for which table it belongs. Every information is stored in the catalog. So it is known as self-describing nature of the database. This allows the DBMS software to work with different database application. If you have a normal DBMS software, right, from this software we can develop any kind of database, whether it is something related to financial or the medical, hospitality, everything, or the education institutes. For every institute we can have our own database by having this a simple DBMS software, right? If we have a general purpose DBMS software which from which we can create any kind of databases. The next one is insulation between programs and data. Insulation is nothing but the separation called program data independence. What it does is, what is the advantage of having an insulation between programs and data is, it allows changing data structures and storage organization without having to change the DBMS access programs. If you go by the earlier versions of the programs and all, which is related to file system, then we have our own module for accessing the information that is present in the system. That is, we will write a program in such a way that it has to fetch the information that is stored somewhere. What happens is, if we change the data type or if we change the organization of the storage, all these things, then accessing program has to be changed. But here it is not mandatory over there, and it is not required also. That is when we are changing some information. For example, let us assume that in a student table we have four attributes, that is name, student number, class, and major. Let us assume that I want to add a next field, that is nothing but the date of birth of a student. Then if you want to implement that one, if you go with the traditional file system and all, then we need to change the program which is used for accessing the information. But here we have a DBMS which takes care of all these things. Just we can change anything over there, not of changing the program which is accessing the data. This is regarding insulation between programs and data. Then we have data abstraction. Here we make use of a data model which is used to hide storage details and present the users with a conceptual view of the database. Here we will not get full information of where the data is, how it is stored, all these things. Whatever information is required for us for accessing the information, only that much is given to the users. Then the programs refer to the data model constructs rather than data storage details. So this makes data abstraction possible. Then we have support of multiple views of the data. That is, whatever the data that is stored in the database, here each user may see a different view of the database which describes only the data of interest to that user. For example, whenever we see the results of a VTU, then for the people who are uploading the marks and all in the website, for them look and feel is different, but the database is same. For the students, like they make use of this database for viewing the information. For them only a different view is shown of the database. In the same way, there will be some people who are involved in other activities. For them, different view of the same database is shown. So it supports multiple views of the data. That is again an important characteristics of the database approach. Then we have sharing of data and multi-user transaction processing. That is, it allows a set of concurrent users to retrieve from and to update the database. That is, concurrent users means at the same time many people can log in into the particular system and they can access the information, they can store the information, they can alter the information, they can modify the information. Everything is possible because of this DBMS approach. Then we have concurrency control within the DBMS guarantees that each transaction is correctly executed or aborted. Now, as we have gone through, there are a lot of people who are using the system at the same time. What happens is sometimes a part of transaction gets executed and then it gets terminated because due to some network failure or something, because of some physical or some virtual reasons over there. Here what happens is if the transaction is not fully completed, then it is rolled back to the previous stage. If the transaction is executed fully, then it will be stored in the database. Permanently the data is going to be stored in the database. This is how concurrency control is possible because of DBMS. Then we have recovery subsystem ensures each completed transaction has its effect permanently recorded in the database. Just now, as I said, whenever there is a transaction which gets fully executed, the updated value is stored in the database permanently. So because of this reason, whenever, let us assume that after the transaction has been completed fully, there is some issue with the hardware or something, then the computer gets restarted or something, then whatever the information is stored permanently, that can be recovered. Then we have OLTP, that is online transaction processing, which is a major part of database application. Nowadays, you can see OLTP systems are everywhere. That is, if you go through your online e-commerce websites like Amazon, Flipkart, eBay, all these things, right? Everywhere we are making use of this online transaction processing systems. Apart from this, we can consider IRCTC booking, right? Wherein lakhs together people or the passengers are traveling from one city to another on a daily basis, right? They they are going to access the same system at the same interval of time, and they are getting they are searching for different results, but they are making use of the same database which is maintained by the IRCTC people. Then we have something known as isolation. Isolation property is nothing but this property ensures that each transaction appears to execute in isolation from other transactions, even though hundreds of transactions may be executing concurrently. If you consider again the example of a train reservation, we might be we might be looking for some train from one city to another, and at the same time there will be lakhs together or thousand together people who are accessing the same database, and they might also search for the same train, right? But we will not feel that someone is also trying to get the same train at the same time and all. We assume that we are isolation, that is we are in isolation, that is we are isolated, that is we are thinking that we are only the people, or I'm only the person who is searching for a so and so train at the same time, because there is no obstacle over here. So that is a property known as isolation. Then we have atomicity. Atomicity property ensures that either all the database operations in a transactions are executed or none are. If I consider an example of ATM, right? We visit a ATM for withdrawing an amount. Now consider a scenario wherein you wanted to withdraw some amount, then you have inserted the ATM card, right? Then you have entered your PIN, amount, everything. Then you get a message 20,000 has been debited from your account. Then due to some hardware failure or network failure something, you are unable to get the amount from the ATM, right? Machine is incapable of giving you an amount. Then what happens is after few hours you get a message, whatever the amount that was debited from your account, it has been credited again. So that is known as automation.